gas metal arc welding, or flux core arc welding. Okay. All right, let's move on. So, it talks about the two basic types of output slope. All right, now in your book, it's the next paragraph down. It says welding machines have two basic types of output slope. Constant current, which is also referred to as variable voltage, and constant voltage, which is also referred to as constant potential. Now, in all of my career, I've never heard them referred to as that. It's either constant current or constant voltage. Okay? Output slope. The output slope is the relationship between output voltage and output current. Let's read it out of the book. I'll read it out of the book instead of the PowerPoint. Okay? Sometimes called the volt-ampere characteristic or curve, is the relationship between the output voltage and the output current, amperage, of the machine as the current or welding workload is increased or decreased. All right? So, it does show us this. Okay. So up here in this corner, it shows your constant current performance. So we're going to be reading it this direction. Again, it does fluctuate some, correct? As it further away we get from the workpiece, it starts to drop off fairly drastically. This voltage is trying to maintain the same. So this is our constant voltage performance. See how it stays pretty well flat. But if we go further away from our workpiece, you're going to see this drop off drastically. Same here. If we're really close, it's going to stay constant. If we're really close to our workpiece, as if this is our work platform, it's going to stay constant. The further we lift up, the further we drop down. Because what are we doing? We're creating an air gap, so there's more resistance there, right? So that electric arc is trying to jump and bridge that gap. And eventually it's going to get to a point to where it just won't run, okay? And this is usually the point in wire when it's starting to kind of hesitate and pull, I want to say, stutter, the wire will, okay? So, at that point, we need to bring it back in a little closer, or possibly turn our wire speed up and voltage as well. Again, essential variables. Things can change drastically. Okay? Now, on our amp curve, it's going to be very similar. Okay? What happens if we lift our stick electrode off the workpiece? It increases as well because it's trying to drive the amperage up to bridge the gap. So it's taking the amps higher, lower. Higher, lower, back down. So not lower, but right back down to where you originally set it. If you're 100 amps, it's trying to maintain 100 amps here. If you take it out there further and you create what we call long arc, so you're bringing your arc distance really far, then you're going to drive those amps up to say 120, 130, 140, and it's really trying to make that electrical jump to find the ground or the workpiece. Okay? Okay, page 288, chapter 11, right-hand column. Look under the bolded points. It said Sheldon metal and arc welding, or Sheldon metal arc welding and gas tungsten arc welding require a steep output slope from a constant current welding machine. Constant current is necessary to control the stability of the arc properly. Next bullet, GMAW and FCAW require a relatively flat output slope from a constant voltage power source to produce a stable arc. And those are the main two that I want to concern you with at this point, okay? But, you know, there's a whole other realm to this as well. So as we get into the metallurgical part, I'm not going to go in deep detail about it, but just to get you thinking in that aspect, okay? The more voltage or the more amperage is also a direct correlation to the amount of heat input we're putting into it, okay? So we have to be very careful how much heat. I mean, we're already starting out the weld puddles at 900 degrees, or 9,000 degrees, I'm sorry. roughly, as high as 9,000 degrees. Melting point of steel is 2,800 roughly, okay, 2780 to 90 depending on carbon content and so forth. However, we know we're above 2,800 degrees, so we're somewhere in that 3,000 to 9,000 degree range. It's a lot of heat already, but it cools off very rapidly as soon as we're done. Doesn't mean that the entire piece stays 9,000 degrees forever. Depends on thickness and so forth. But the more amps that we put into it creates more heat, also creates more distortion, creates chemical, or not chemical, but discontinuity, grain boundaries, and a lot of other things that we're going to get into later on. But the main portion of that is I want you to think about, start thinking, well, I need to watch how much heat I put into a piece of material as well. Because you don't want to build this really nice box, put a bunch of heat into it, and then you're done, and you look down it and it's nice and wavy because it distorted and warped because there was too much heat input. You didn't slow down, you didn't weld it properly to where it come out nice and flat and even, okay? So just something to think about. Moving on. Each arc welding process has characteristic output slope. We just read from this, requires a steep output slope from constant current. However, GMAW and FCAW require a relatively flat output slope from constant voltage power supports. All right, engine-driven generators. So basically, engine-driven generator welding machine type is the one that you would see going up and down the road, most commonly associated with service trucks of equipment or pipeline welding, so forth. It's usually the Lincoln or the Miller machines that we see on the back of the truck. It's got its own engine, which in turn, the engine turns the generator, produces a electrical charge coming out of it, okay? Types of power source, we're here on engine-driven generators. These are powered by gas or diesel engines. These machines can also be found with an AC or DC electric motor as their power source. However, they are no longer being manufactured and are rarely found in an industry today. So I believe what they're referring to there is just the AC or DC electric motor that's producing this. Everything that's the gas and the diesel engine, they're still being manufactured every day. But it's the engine, it's the engine driven, the engine will be powered by an AC or DC motor instead of a gas powered motor, okay? All right. Transformer rectifiers. They use basic electrical transformers to step down AC line power voltage to an AC welding voltage. So let's say our line power voltage outside is going to be 7,200. We don't have 7,200 volts in the wall, do we? No, it goes through a transformer process to step it down to 120 degrees so that we can plug most of our appliances in, because that's a safe working voltage for residential homes and businesses. Most welding voltage is either going to be a 480 or 240, okay? AC welding voltage, it can be either a three-phase or a single phase. Welding voltage then is passed through the rectifier to convert AC output to DC welding current. So at this point, we still have an alternating current, and we are converting it to a welding current, which is direct current, which gives us a lot more control and heat input as well, a lot less heat input as we're going into the welding cycle on the DC side. You can read through this on your book. AC transformers, they use to step down AC line power voltage to AC welding voltage. So it'd be the same thing as we had here, but instead of converting it from alternating current to direct current, this is just leaving it as alternating current. Now this is typically what you would find in most of welding. You go to, say you go down to Coastal or even the supply house, and you're buying a $300 to $400 welding machine. Okay, most of them, what we call as the ranch welders, our ranch welding machines, are usually going to be of an AC welding voltage type. They're a lot more affordable. You can usually find electrodes that are AC welding electrodes that you can fix stuff around the house and the farm fairly efficiently. Okay. All right, inverters. Now inverters have really picked up. It's amazing. You know, 20 years ago, and we have some out in our shop even, you know, sometimes you'll have this machine that's this big. Being as a welding machine, it's huge. And then you go to the back and you'll see one of the newer Miller XMT 304s, and they're only like 40 pounds. They put out just as many amps and volts as that big welding machine does. So we really condensed, we've been able to invert and step up the amount of voltage, the output voltage coming in, okay? So it increases frequency of incoming primary power. You can find them in constant current voltage or both. They produce AC or DC welding current. Now not all of them. Some of them, let's explain this a little better. You can get them that they can produce an AC or a DC. You can get machines that will produce both. But a lot of times when you're looking at machines like that, they're going to bring the AC line voltage in, they're going to convert it to a DC welding current, and that's what you're going to weld with. It's also going to amplify it, create some frequencies in there to where it creates a lot more stable arc. So the control is a lot easier. There's a lot less chance of it kind of going goofy and getting a magnetic arc flow and so forth within the material. So some machines will do AC and DC, some will do only one or the other, okay? You can pay, you know, the average price of these are from $1,200 to, you know, I think $10,000, $12,000 if you really wanted to get a multi-process machine that would do quite a bit. Be AC and DC both. It's important to select the right power source for each job. Okay, so for example, I would not want to run direct current if I'm welding aluminum. I can get the strike and arc and go, but it's going to melt and just be a horrible arc, very little control. You're going to end up with a lot of hot shortness, which just basically the aluminum is going to lose its molecular structure and just drip out and just fall on the ground. However, if I welded it with an AC voltage, I could step it down, get a lot more controlled arc, nice good weld, high quality, code quality weld. Okay? Make sure that you're looking at and thinking about what am I supposed to be using, what power source? Is it alternating current or is it direct current? What do I need? Okay? So I want to go to the book real quick. Table 11.1, it says, shows I don't know where this is. Table 11.1 is on page 297. It shows the characteristics of three basic types of welding machines. Okay? You can look at the weight difference. If you look at the DC inverter, it's 76 pounds versus an AC transformer is 573. So when we start talking about differences in size and portability, big difference. Okay? Talked about some of this. Feel free to go back through this PowerPoint, study, refer to your book as well if you need to. Okay, now we're going to step into open circuit voltage. So, chapter 11, page 289, right hand column towards the top, starts out, second paragraph down, it starts out open circuit and arc voltage. Open circuit voltage is the voltage generated by the welding machine when no welding is being done. The machine is running idle. Arc voltage is the voltage generated between the molten tip of the electrode and the surface of the molten weld pool during welding. It's also referred to as arc length. Well, let's not worry too much about the arc length. Okay, so the open circuit voltage is what's going on. Say you're getting ready to weld, you're looking there, but you haven't quite struck the arc and got it to where the electricity will make that jump, okay? It's the amount of voltage. So say we're set at 120 volts, okay? Where it becomes very important is in certain places, again, with a lot of humidity. So Portland on a rainy day, winter months, quite possibly in the south where the humidity is 97, 98% humidity, you can start getting shocked from the open circuit voltage being too hot without even touching the electrode to the workpiece, okay? So that's why most machines now have a protection in them to where it takes the 125 amps and it makes sure that the open circuit voltage is stepped down like 25 or 30. You can't take it to 0 because then it would take forever to get it going again. So they take it down to about 25, 30. Once you strike the arc, it takes a second or two for it to ramp up, especially in an engine-driven machine. The engine will ramp up to a full throttle, and then the electricity will start again. Well, it's the same thing on a transformer. It takes a second for the electricity to go through the path, boom, and then it starts back to 125 amps. Open circuit voltage, where you're not making a connection, drops it down. Hopefully 30 is what you're looking for. I believe OSHA standard is 30 to 35, somewhere in there, I believe, without looking it up. Okay? Now the arc voltage is the voltage generated between the electrode and the work during welding. Now we can test the voltage, and we can even test the amperage too, but we can put a voltmeter between this, and say we come back to the machine, or we can find a hole. A lot of times we'll have a connection here, or you can even come here to a bare wire, and you can check your voltage between the two, and you'll see what your voltage range is, okay? Now your amp clamp, you put your amp to be able to check your amperes. It has to be a DC in most cases to be able to clamp around here, which most of the ones that we use for electricity are an AC type amp clamp. That's how we check amperage. So you have to have a special amp clamp that's able to read direct current amperage as well. But just to give you an example, when we're writing procedure qualification records, or when we're proving procedure qualification records of a procedure, I'm required, and when I test welders, a lot of times I will check the voltage within their machine, what is going on between ground and positive, to see how many volts are going. There's usually a window, so say if it's, say especially if we're doing voltage and you're set at 18 volts, the welding procedure may tell you it can only be between 18 to 23 volts. That's your window. So say if somebody's trying to drop it down to 16, you're out of the range, that procedure is no longer valid. Okay. We can also tell a lot of things. If you are constantly, if your voltage is fluctuating up and down, your wire speed might be off. You may have a set of rollers that's gunked up or slipping. You also might be fluctuating quite a bit as far as your arc length or your stick out, electrode extension. Okay. All terminology we'll get used to going through the welding program. Again, more resistance, your volts are going to go up, or amps are going to go up, so forth. Okay? Let's get back on that. Let's come back into here. So right here it says open circuit voltage runs between 50 to 100 volts. This is 2012. Last Lincoln Vantage 500 we had, job site, it said it was down around 32 to 34. The last 4 or 5 years, they've made some advances to try to get that down a little bit more. Arc voltages, 36 to 18. Now notice, these are voltages, not amperage, right? So your amperages can be a lot higher as well. So as the arc is lengthened, arc voltage increases, current decreases. You constantly have to have one or the other. If voltage increases, amperage decreases. Vice versa. Okay, they're in direct, inverted proportional limits. All right, open circuit voltage on constant current machines higher than most constant voltage machines. Right here, arc voltage depends on the physical arc length at point of welding and controlled by the welder. So what they're saying here again is your arc distance. Okay, whether if you're really, really close, you've got too short of an arc distance, too short of arc. If you're really far away, then that's what we call long arcing. Okay, and those are proper terminology according to the AWS welding definitions and terms, a short arc or a long arc. Okay, so as we come up, goes through the roof, coming closer, comes back down to normal. If your amperage goes up, your voltage decreases. If your amperage goes down, then your voltage increases. Okay, I hope I said that right, but they're directly opposite. All right. Desirable characteristics. Trying to figure out where exactly we're at in the book. Has forceful penetrating arc, versatile, can be used to weld all metals that are weldable by arc processes, flexible, can be used in all positions, durable, give long life if properly maintained. Okay? All right, let's go to engine-driven machines. Classified by the type of motor that drives the generator, whether it be a diesel engine or a gas engine. Very similar to the Miller Trailblazer 304, or not 304, but Miller Trailblazers. This is Lincoln Series. You'll see both of them going up and down the road. They're both good pieces of equipment. They have their perks. You'll find folks that either like one or the other. It really depends. I owned a Lincoln 300 on my welding truck. It's a very good machine, very dependable. By far, it welded 60-10 5P. I thought that the arc was much more stable than any Miller machine, engine-driven machine I have run. However, when it comes to electric running or electric machines, transformer type and so forth, not an engine-driven, in the shop, it's hard to beat Miller's equipment. They've got 4 drive rolls versus 2, really stable arc. They're both good pieces of equipment. They are both prominent companies because of that reason. They both provide good equipment. All right, go back to it. Consists of a DC generator and an exciter built on a single shaft, or the alternator. Generators used in the field. I want you to get a chance and look up and see how an armature works. If you get a chance, look up a diagram of a welding armature. Okay, it'll give you something to